Hi, welcome to your lesson on the sum of a geometric series. Let's begin with a classic problem. If you were offered, which would you take? 1. $150 billion, or 2. A chessboard with $1 on the first square, $2 on the second square, 4 on the third square, and so on. So basically you're doubling the amount on each square. A chessboard, so you know, I believe is 64 squares. Right? Ponder that, make your choice. Okay, so here's a chessboard. First one had $1 on it, so that's actually 2 to the 0 power, because anything to the 0 power is 1. The next square had $2 on it, that's 2 to the first power. The next square had 2 to the second power, which is $4 on it, and it continues like that. There's a pattern here. All right, so when you're doubling, it's actually 2 to an exponent like this. And you keep going, and there's $16 there, $32, $64 on that one, $128 on that one. And it keeps going. Right, I'm going to skip a few. By the 12th square on the chessboard, you already have 4,096 on that square. By the 17th, we have 131,000, but it's not nearly close to 150 billion yet. So maybe if you chose 150 billion, you made a good choice. By the 26th square, we have 67 million. All right, it's getting bigger. Now, don't forget that you get all the money on your chessboard. This is just how much money is on the 26th square, but you would still get all the money on the 25th, 24th. So actually, you'd have to add up all of these to get your total amount. All right, on the 42nd square, we have 4. Whoa, it's not even billions, it's trillions already. So you have already exceeded 150 billion on the 42nd square, and you're not even to the 64th yet. And again, you're adding it all up. So if you added all of these up, you'd get this crazy big number. It's 18.4 quintillion. So if you chose the chessboard as your way of making money, much better choice than the 150 billion. Look how quickly those numbers went up. That's amazing. All right, so the history of this problem is that it is an old Indian fable which illustrates how the terms in a geometric sequence grow. A prince was so taken with the new game of chess that he asked its inventor to choose his reward. The man said he would like 1 grain of rice on the first square of the chessboard, 2 grains on the second, 4 on the third, just like we had, doubling every time. This seemed so little to ask that the prince agreed straight away. Servants started to bring in the rice, and to the prince's great surprise, the grains soon overflowed the chessboard to fill the palace. All right, just so we know, this is something I can't remember the exact number, but it's 100 something times what the whole Earth can produce in grain for the whole year. All right, so our sequence was that 1, 2, 4, 8, 16, 32, 64. And that I hope you recognize as a geometric sequence. You're multiplying each term by 2, so the R value is 2. And again, the sum of the first 64 was this giant number, 18.4 quintillion. So our goal today is to learn how to find the sum. There's a formula for it. So let's take some notes. This is going to be back in that 2-page packet that you have with all our formulas for this unit. And we have one space left over. It is the sum of the first n terms in a series. Again, series means a sequence where you're adding all the terms. And you're under geometric, right? So the formula to do this, sum of a geometric series, is this formula. And this S means sum of number of terms you're adding. So if it was 5 terms you're adding, it would be sum of 5. And you plug everything in here. Here's our ratio. Here's our n value again. And the first term is here. So here's an example. A geometric progression has the form 6, 2, 2/3, and so on, ... Find the sum of the first 10 terms. So again, we need the first term and we need the R value to find that sum. So the R value here, how do you find it? Well, again, to find the R value, you can always divide the one term by the previous term. So here, I would divide 2 by 6, and I would get the R value. 2 by 6 can be reduced to 1 over 3, so 1/3. That makes sense. These are being multiplied by 1/3 as you go here. So here's our sum formula. Sum of the first 10. Here's our first value, our first term, 6. Then you always have a 1 here. 1 minus the R value, 1/3 in this case, to the 10th power, because we use the n. And then on the bottom, 1 minus 1/3. Now, the only way this can go wrong is the way you punch in your calculator. You have to be very careful how you do this. That's the most frequent cause of error here is the way students punch numbers in. Try it on yours, and hopefully you got this number here. All right, so if you didn't, double check the way you're punching things in. All right, the other problem is on the second attached page on the very back, our last problem on that page. A geometric sequence follows this pattern here. It has a common ratio of 0.5. It didn't need to give you that. You could see it here. 0.5 means half of 16 makes 8, so half every time. Find the value of p. So try that now. Right, hopefully you got p equals 4 because these are being multiplied by half every time, so half of 8 would be 4. Okay, find the value of the 7th term. Try that now. All right, to do that, you're going to use your regular nth term formula. This is not a sum, it just says the value of the 7th. So what is the 7th term? You're going to use that formula, and you're going to put u7, first term is 16, times the r value, 7 minus 1 here. And u7 is 0.25. And final question says, find the sum of the first 15 terms. So now you're finding the sum. If you wrote out this sequence, all 15 terms, the first ones, I guess you could write all 15 out and then just do 16 plus 8 plus plus, but the formula is much quicker, so try the formula. All right, here's sum of the first 15. First term, 1 minus the ratio to the 15th power, and 1 minus the ratio. Again, make sure you punch in carefully, and hopefully you got this answer here. So that's it for that packet, which has our 4 formulas and example problems of all kinds. Let's try one more. So in your notebook or on some page, try this one. Find the sum of this geometric series. All right, so you have this, looks like a pretty long series because it goes from 16 and then there's this bunch of terms we don't see and it gets all the way up to here. Yeah, I'll give you a hint. You definitely need to know which term number this is before you can find the sum. Great, here's how you do it. So to figure out which term number this one is, you use the regular formula for nth term. You put 8192 in for un. You replace this, u1 is 2, and the r value is also 2 because you're doubling these every time. All right, then I can divide by 2 right here to get to take away this 2 and be left with this equals that. Now, using your calculator or just kind of guessing some numbers, you can find out that n is actually 13 because 2 to the 12th power makes this. If n is 13, this is the 13th term in this sequence, and we can use the sum formula to find the sum of the first 13 then. And that is what this sum formula gives you. All right, so now you know all your formulas, and be ready to review some more before we have an assessment next week. All the best.